Okay, guys, we're here today to talk about law of cosines. This is Math Note 7.2.3. And so, law of cosines, just like law of sines, the law of cosines represents a relationship between the sides and angles of a triangle. But law of cosines is going to let us do some stuff that we weren't able to do with law of sines. If you recall from law of sines, in order to use law of sines, we needed to have an angle and a side that were opposite of each other. So you had to have B or A or C or C, so that you could set up this ratio and then solve for the missing stuff. Law of cosines is going to let us solve those triangles when we don't have an angle and a side that are opposite each other. So specifically, when given the lengths of any two sides, such as A and B, and the angle between them, the missing information in the triangle can be found using this relationship right here. So this says if you're trying to find side C and you have A and B and angle C, now that's something we can do. So to find the missing side C, we have A squared plus B squared minus 2AB cosine C. And then by extension, these other relationships are also true. So one way to sort of help you remember that is that if you're solving for side C, you're going to use angle C. If you're solving for side A, you're going to use angle A. If you're solving for side B, you're going to use angle B. And they all follow the same pattern after that. So let's look at a little example of that. If we look at this triangle up here, we are given this side is 15, this side is 28, and this angle is 82. With law of sines, we would not be able to solve it because we don't have any angle and side pair that are opposite each other, but we can use law of cosines to do that. So side C is equal to A squared plus B squared minus 2AB cosine C, which means 28 squared plus 15 squared minus 2 times 28 times 15 times the cosine of angle 82. And those are our sides that we're given there. Which we'll crunch some numbers now, and we get C equals 29.9. Now, after you figured out that C is equal to 29.9, then you can use that information in law of sines to find the missing sides. And generally, the math in law of sines is a little bit easier. The formula is a little easier. So, typically what I'll do is use law of cosines to solve for the first missing thing, and then once we have the relationship where we can use law of sines, switch to that. So now we can say sine A over A, and get sine of A over 28, is equal to sine 82 over 29.9, and figure out that A is 68 using angle sum theorem, or the angles in a triangle add up to 180 degrees to find the third angle of 30 degrees. Okay, so now is your turn. Go ahead and do that for these two triangles here at the bottom. Draw and solve each triangle below. Round the measure of sides to the nearest tenth and the angles to the nearest degree. I would start with law of cosines. Once you have a pair of opposite side and opposite angle that match each other, switch back to law of sines and figure out the rest of the triangle. All right. Have a good day, sir.